Hello students, in this class I will teach you Hamilton's canonical transformation equation of motion. We know canonical functions, we know canonical variational principle, then we calculated or we derived Lagrangian equation of motion from variational principle. Now in this class I am going to teach you how Hamilton's canonical transformation equation of motion will be derived. For this we use Hamilton function, Lagrangian function, etc. All we studied already. We will use the same equations here to derive canonical transformation equation. Okay, we will see now one by one. We know that the Hamilton function h, it will be represented by the letter h. Hamilton function h is given by this equation we already know in the Hamiltonian function itself. H is equal to h into qi, pi and t. That is, the Hamiltonian function depends upon three coordinates qi, pi, t. Qi is the position coordinate, pi is the momentum coordinate and t is the time. You make it equation number 1. We already saw these in the previous videos. You just watch the video and notes and you will follow the things. Okay, h is equal to h into qi, pi, ti. Now differentiate this equation 1 on both sides. Differentiate equation 1 on both sides. So what will happen? H dh, that is equal to, here there are I number of terms, therefore summation of I, then h will be differentiated, partially differentiated with respect to qi and dqi plus summation of I dou h by dou pi into dpi plus dou h by dou t into dt. This is equation number 2. Okay, so we are taking first Hamiltonian function h is equal to h of qi, pi and t. Then we are differentiating this equation 1 both sides. Therefore dh is equal to summation of I dou h by dou qi into dqi plus summation of I dou h by dou pi into dpi plus dou h by dou t into dt. Now we also know Hamiltonian equation h is equal to summation of I pi qi dot minus L. We also know this equation also. That is the relation between Hamiltonian function and the Lagrangian function. Here pi is the momentum coordinate and qi is the velocity coordinate. Therefore h is equal to, we know that h is equal to sigma I pi qi dot minus L. All these equations we already studied. Okay, I am using the same equations only. Now differentiate this equation 3 on both sides. On both sides. Now what will happen? dh is equal to, this is the uv function, that is first function d by dx of second plus second function d by dx of first. Therefore summation of I first function d by dx of second, that is differentiation of second function plus summation of I second function differentiation of first function. So this term is over, minus dl. L is differentiated, so dl. So you make it equation number 4. Understand? Now, where L is the Lagrangian function, we know that Lagrangian equation or Lagrangian function L may be written as is L is equal to L of this Lagrangian will be depends upon Qi dot and T. All these things we already studied in the earlier classes. Okay, so you just recollect it. L is equal to L of Qi dot and T. You make it equation number 5. Now, sorry, differentiate this equation 5 on both sides. Differentiate equation 5 on both sides. Now what will happen? Why I am differentiating? If I am differentiating and I am going to calculate the value of dl and I will substitute the values in this equation 4. That's why I am now using this Lagrangian function L here. So L is equal to L of Qi dot T. In order to find out the differential value of L, I am using this function and now I am differentiating. Therefore dl, that is equal to the same procedure, summation of I dou L by dou Qi into dqi plus summation of I dou L by dou Qi dot dqi dot plus dou L by dou T into dt to make it equation number 6. Okay, right. Now we know that dou L by dou Qi dot equal to Pi. This also we already derived in the Hamilton function derivation. Okay, so dou L by dou Qi dot equal to Pi. You make it equation number 7. Dou L by dou Qi dot, that is equal to Pi. We know this. Similarly, we know Lagrangian equation. What is Lagrangian equation? D by dt of dou L by dou Qi dot minus dou L by dou Qi equal to 0. We know this equation. Now d by dt of dou L by dou Qi dot equal to dou L by dou Qi. You just change this to the right hand side, thus the minus symbol will become positive. Okay, so d by dt of dou L by dou Qi is equal to dou L by dou Qi dot. Dou L by dou Qi dot. You make it Qi dot. You see this equation number 7, dou L by dou Qi dot is nothing but Pi. Okay, dou L by dou Qi dot is equal to Pi. Therefore here you substitute the same value Pi. What happens? D by dt of Pi is equal to dou L by dou Qi, or d by dt of Pi is nothing but Pi dot. Okay, Pi dot, that is equal to dou L by dou Qi. Make it equation number 8. Pi dot, that is equal to dou L by dou Qi. Now you see, we know the value of Pi, that is equal to dou L by dou Qi dot. Dou L by dou Qi is equal to Pi dot. Here now substitute this value of 7 and this value of 8 in equation 6. You see, instead of dou L by dou Qi, you substitute Pi dot. dou L by dou Qi dot, you substitute Pi. Understand? So, in the place of dou L by dou Qi dot in equation 6, you substitute Pi dot. Dou L by dou Qi dot, you substitute the value of Pi here. So, now equation 6 becomes, now the equation 6, we may write it as, substitute the values. What will happen? Equation, now 6 becomes dl, that is equal to summation of Pi dot into dqi plus summation of Pi dqi dot plus dou L by dou t into dt. This is equation number 9. Understand? So in equation 6, I am substituting the value of dou qi as Pi dot and dou L by dou qi dot as Pi. I am making this equation number 9. So we find out now the value of dl. Now what I already told, you substitute the value of this dl in equation number 4. In equation number 4. What will be the equation number 4? So substitute the value of dl from equation 9 to equation 4. So now what will be equation 4? dh is equal to summation, you just refer it, dh is equal to summation of I Pi dqi dot plus summation of I Qi dpi minus dl. In that place of dl, you substitute the above value 9. So what will happen now? Equation 4 becomes dh is equal to summation of I Pi dqi dot plus summation of I Qi dpi minus, instead of dl, you substitute these values. Summation of I Pi dot dqi plus summation of I Pi dqi dot plus dou L by dou t into dt equal to 0. Not 0, dh, instead of dh, na? Okay. Now you understand? Now dh is equal to, you just expand these terms. So sigma psi Pi dqi dot plus summation of I Qi dpi. Now multiply this minus going inside, Pi dot dqi minus summation of I Pi dq dot, then minus dou L by dou t into dt. Here this term and this term cancels each other. It is plus, it is minus. So what will be the remaining term now? dh is equal to summation of I Qi dpi. I think it is Qi dot, I think so. Okay. Yes. The equation number 4, it is Qi dot into dpi. So it is Qi dot. This is also Qi dot. This is also Qi dot. So Qi dot dpi minus summation of I Pi dot dqi minus dou L by dou t into dt, to make it equation number 10. Okay. Now the important term. Important work is dh is equal to summation of I qi dot dpi minus summation of I pi dot dqi minus dou L by dou t into dt. This is equation number 10. Now compare equation 2 with equation 10. Now compare equation 2 and 10. 10th equation is this. What is this? Second equation dh, that is second equation is dh, I am again writing here, dh, that is equal to summation of I dou h by dou qi into dqi plus summation of I dou h by dou pi into dpi plus dou h by dou t into dt. So this is the second equation. Now compare this second equation with this equation number 10. How? That is, compare coefficients of dqi, dpi and dt in 2 and 10. Okay. Compare the coefficients. Take equation number 2 and equation number 10. Compare the coefficients of dqi, dpi and dt. Okay. Now what will happen? You see, what is the coefficient here? dqi dou h by dou qi. What is the coefficient here? dqi minus pi dot. Okay. So dou h by dou qi, that is equal to minus pi dot. What is this? This is the coefficient of dqi. Okay. So this is one canonical transformation equation. Then what will be the coefficient of dpi? You see dpi, where is dpi? Here in equation 10, dpi is qi dot. Here pi is dou h by dou pi. Therefore dou h by dou pi, that is equal to qi dot. This is the coefficient of dpi, and this is another canonical equation. Dou h by dou pi, that is equal to qi dot. Now another thing is coefficient of dt. Coefficient of dt is what? Dou h by dou t, that is equal to dou L by dou t minus dou L by dou t. So coefficient of dt should be what? Dou h by dou t is equal to minus dou L by dou t. This is another canonical transformation. So we got 3 canonical transformation equations. One in terms of pi, another term in terms of qi dot, another in terms of dou L, that is in terms of the relation between h and Lagrangian, that is dou h by dou qi, that is equal to minus pi dot, dou h by dou pi, that is equal to qi dot, dou h by dou t, that is equal to minus dou L by dou t. These 3 equations are called canonical transformation equations, and you should remember these equations always in classical mechanics when you are using Hamiltonian functions. So these three equations are very important equations. Dou H by dou Qi equal to minus Pi dot. Dou H by dou Pi is equal to Qi dot. Dou H by dou T is equal to minus dou L by dou T. So these equations are called as Hamilton's equations of motion or Hamilton's canonical equations of motion. So these equations are called as canonical transformation equations. Okay, so these are very important equations we will use in many places in classical mechanics. Hope you will understand all these things. You follow my video and my notes also, so it will be very useful for you. If you have any doubt, you may ask queries in Google Classroom or in WhatsApp, anyway. Okay, thank you.